Today we are starting our trig unit, and we're going to do some of the basics of angle measurements and different trig functions, just to get a basic idea of what's going on. A lot of this should be reviewed from Algebra 2, and some of this we're even going to try with the calculator. So the first thing we're going to do is take a look at converting some basics, degrees, minutes, seconds, to degrees and vice versa. So we know our basic degree symbol, it's a unit of angular measure. In the DMS, or degree minute second system, each degree is subdivided into 60 minutes, and each minute is subdivided into 60 seconds. So just kind of conversions that we need to keep in mind. For this first problem, converting it to degrees, minutes, seconds, we want to think the portion that we really need to change is really after that decimal point, because that's going to be a part of a degree. So we want to figure out how much of that degree then is in minutes and in seconds. So the first thing I'm thinking is if I take what's that extra part of the degree, that 0.425, and if I'm trying to convert it into minutes, then I have to think, well, multiply it by that 60 minutes per degree. And if I multiply that out, I'm going to think 25.5 minutes. Okay, so now I have an extra, again, little bit of a minute. I have an extra 0.5 of a minute, and I want to think, well, how many seconds is that? So if I multiply that out, that would get me my 30 seconds. So if we put this all together, I have 37 degrees, 25 minutes, and 30 seconds. Now the nice thing is that you can do this on your calculator. Always good to know how to do it by hand. But your calculator, if you were to type in the 37.425, and I can go to my catalog. So if I go to my book, and perhaps an easy way to search for this, if I press just the letter D, that brings me up to all of my commands that begin with the letter D. And I'm going to scroll down until I actually find our DMS, which is right there. And I press enter, and I press enter again, and that will turn it into degrees, minutes, seconds. Now, if you notice on our calculator, we're not getting the same answer. So something that you got to check is to make sure that it's actually in degrees. Right now, our calculator is in radians. So if I go back to the home page and I change our document settings, I want my angle to actually be in degrees and say make it a default. Now if I go back to my current page and I try this again, I will actually get the right answer. So if for some reason you're doing this, and this is just kind of a check for yourself, that 37 should always be your degree. All of a sudden our 37 turned out to be 2,144 degrees. That's your key to saying, hey, something's wrong. So just double check that your calculator is in degrees, and then you have a degree, minutes, seconds. Okay, going in the opposite direction, so now it's already in degrees, minutes, seconds, and I want to convert it back to degrees. So the 42, again, that's already in degrees. It's the extra part that we have. That 24 that we have, that's the 24 minutes. That's 24 out of 60. And to that, I want to add on our 36 seconds. But that's, now seconds, I have to think seconds are part of a minute, minutes are part of a degree. So for each second, it's really equal to 1 over 3600th of a degree. So that means I have to divide that by 3600. Okay, and when we do this, again, you can plug this right into your calculator, and you're just going to get 42.41 degrees. Now for this conversion on your calculator, we do have a nice template that we can use. In our template, if we go to our button, you're going to see it's this one right here in our second row, second one in from the left. And then that just says type in what you have. So I would type in 42 degrees, tab over. I would type in 24 minutes, tab over. I would type in 36 seconds, press enter, and that would do the conversion. Again, you have to make sure it's in degrees. If not, you're going to get a weird answer. But that does the conversion for you. Okay, moving on to some radians. A radian, we just want to make sure we understand 1 radian, if it intercepts an arc with the same length as the radius. A central angle has 1 radian measure as long as it intercepts an arc with the same length as the radius. Conversions that we did back in Algebra 2, converting from radians to degrees and degrees to radians. So for instance, I right now have 90 degrees and I need to convert that to radians. So I want to think I'd multiply that over, by pi times, we'll try that again. Multiply that by 90 times pi divided by 180. And if I do that and reduce, keep it in pi form, I'm going to get pi over 2 radians. Going in the opposite direction, I already have radians, pi over 3, and I need to figure out degrees. So our conversion is the reciprocal of what we just did, 180 over pi. And if I simplify this down, 180 divided by 3, reduce that out, that's going to get me 60 degrees. One other formula that we had used last year in Algebra 2 was our arc length formula. And our arc length formula was S is equal to R theta, where S was your arc length, and theta is your angle, but in radian measure. That's huge. You want to remember that. This needs to be an in radian measure when we're using this. So we're finding the length of an arc, so we're finding S, intercepted by a central angle of 1/2 radian in a circle of radius 5 inches. So I'm trying to find S. I have a radius of 5. I have my central angle of 1/2 radians. It's already in radians, so I don't have to do a conversion. So that means my arc length is going to be equal to 2.5 inches. Okay, so just a little summary. To convert from radians to degrees, we want to think multiply by 180 over pi. And to convert from degrees to radians, we're multiplying by pi radians over 180 degrees. Okay. I always think wherever I'm going needs to be on top. So if I want to convert it to radians, I want to think radians on top. If I want to convert it to degrees, I think degrees on top. Okay, and this arc length formula, that's what we just did on the other page. And again, big thing here, theta is measured in radians. You want to keep that in mind. So our arc length formula we have is S is equal to R theta. So applying this, so we're going to find the perimeter of a 60-degree slice of pizza, because I know we always do that. And if I think, here's a piece of pizza, I have 60 degrees, and it says it is a 7-inch radius. So if I'm finding the perimeter, then what I need to also find is our arc length, which is right here. That's where your crust is. So I have our formula, but the thing we have to remember is theta has to be in radians. So the very first thing we need to do is convert that 60 into radians. And to do that conversion, going to radians, radians on top, pi on top, I think pi over 180. And if I reduce this down, I'm going to see this simplifies to pi over 3. So now that's going to be our theta. So in our formula, we have S is equal to R, which is your radius of 7, times theta, which is pi over 3. So we could get a decimal form. We could keep this as 7 pi over 3. It's up to you. It turns out to be approximately 7.3 inches if we did the conversion. And so our perimeter, we're just going to add up all the sides. So I have 7 plus 7 plus 7.3. And when we simplify, I can get somewhere around, 21.3 inches for our perimeter. So that was just using that arc length formula. Okay. Moving on to some other angle properties. Again, quick review on some angles. When we are looking at trig and basic angles, Typically what we do is we put our angle in standard position. If I'm looking at this angle on the axis, I can think standard position. This is what we called our initial ray, and this was our terminal. Okay, some other things when you're in a right triangle, I'll tell you that's a right triangle. This is your hypotenuse, always. And if I am using this angle, anytime you're doing trig, always pick the angle that you're working with, and then you can determine the opposite side from that angle, and you can determine the adjacent side. But it's always according to the angle that you're using, so you have to pick it first. If for some reason we were to use angle B, notice it would change. Now your opposite side is this one, and now your adjacent side is this one. So notice that they switch, got to be careful. Okay. Some basic ratios, again, we used these last year, used these in the geometry. Basic ratios that we need to know for sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now these next three are the reciprocals, meaning flip them. So cosecant, abbreviated CSC, is going to be the hypotenuse over opposite. Secant, here's your abbreviation, SEC. Again, reciprocal of cosine, so we get hypotenuse over adjacent. And your cotangent is the reciprocal of tangent, and that's the adjacent over opposite. So these are things we need to have committed to memory. And then when we are applying these trig functions, we're going to take a look right now at two of the triangles that we will need to have committed to memory. Again, we should have used them last year in Algebra 2. And then we're going to see how we can apply the other formulas. So we're going to try and find the values of all 6 trig functions for an angle of 45 degrees. So there's two different ways that you could do this. One is if you're considering the unit circle meaning your hypotenuse or your radius is a length of 1. And then the sides would always get a value of radical 2 over 2. That is one option. Another option, and usually the one that I use in class, is where I consider the side lengths to each be 1 and my hypotenuse to be 2. So I'm going to show you how that one works. If we were to make up our ratios, I'm thinking sine of theta, theta being 45, our sine value in this triangle I could see would be opposite over hypotenuse. Sorry, that should be square root of 2. Opposite over hypotenuse, so I would have 1 over radical 2. Now, if I were to go to this original triangle, I would have opposite over hypotenuse, which would get me radical 2 over 2. Well, if I rationalize this denominator, meaning get rid of the square root in the denominator, notice I'm going to get the same thing. So that's why I said it doesn't really matter which triangle you use. I seem to like the second one a little bit better, but it will get you the same answer. Okay, cosine of 45. So cosine's adjacent over hypotenuse. So cosine, you get 1 over square root of 2. Tangent of 45 is opposite over adjacent, which would give me 1. And now the next three are our reciprocal functions. So our reciprocal function of sine is our cosecant. If I think of sine as being 1 over radical 2, well then cosecant, the reciprocal, is radical 2. Reciprocal of cosine is secant. And if I, again, do the reciprocal of 1 over radical 2, I get radical 2. And cotangent, the reciprocal of 1, is 1. And if we did this again for number 7, finding the values for an angle of 30. So again, two different ways we can take a look at it. If I did the unit circle, these would be the sides that I would probably need to commit to memory. Okay, if I didn't do the unit circle, but I perhaps built the triangle each time we did it, if that's my angle of 30, I know smallest side is always opposite my smallest angle. The biggest side is always my hypotenuse. and the one in the middle is going to be opposite my middle angle. So again, if I'm trying to find the sine of this angle, sine of 30, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And everything right now is in relation to 30. So where I have sine of theta, I could really say sine of 30 because I know theta is 30. Okay, our reciprocal functions. The reciprocal of sine is cosecant, which would be 2. Reciprocal of cosine is secant. So if I flip it, I get 2 over radical 3. And the reciprocal of tangent is our cotangent. And the reciprocal turns out to be radical 3. Okay. And our last one that we have is, what if they haven't given us an angle, but they've given us the sides? So they're telling us we have a triangle where I have an angle of theta, and I know according to this, my sine ratio, my opposite over hypotenuse, is 5 over 6. So what that does is it fills in 2 out of the 3 sides of the triangle, and we can find our third side by doing Pythagorean theorem. And if we solved and we found this, x turns out to be about the square root of 11. So now all 3 sides are filled in, and now you can find all of your ratios. So we already knew sine of whatever this angle was 5 over 6. Okay, cosine, adjacent over hypotenuse. So according to this angle, here's my adjacent hypotenuse, so I get square root of 11 over 6. Tangent, I have opposite over adjacent, so I'd have 5 over square root of 11. And now we can find the reciprocals. So the reciprocal of sine is cosecant, which is 6 over 5. The reciprocal of cosine is secant, which is 6 over the square root of 11. And the reciprocal of tangent is cotangent, and that's square root of 11 over 5. So that's just some basics, a little bit of review. We will get into this more in class, practice a little bit more. Don't forget to like and subscribe. Have a great day.